Now let's look at the mistakes people make with stacks. Most of them come from skipping a guard. Let's see the most common one. This pop looks fine, but it has a real bug. The function is as pop buggy. It takes an array stack and an out pointer, but it never checks whether the stack is empty. This line reads s-arrow data at index s-arrow top. If the stack is already empty, s-arrow top is -1, so this reads before the array. Then we decrease top by 1, so s-arrow top goes from -1 to -2. The next bad pop reads even further out of bounds. Let's walk through why. If the stack is empty, top is -1 before we read anything. So s-arrow data at index -1 reads one slot before the array. That is undefined behavior. You get garbage or a crash. Then we decrease top by 1, so top goes from -1 to -2. The next call reads even further out of bounds, and it gets worse each time. The symptom is nasty. You get garbage values or a crash, often several calls after the first bad pop. The fix is simple. Guard every pop and peek with is empty first, exactly like the real as pop does. Now a check. Which single line in the correct as pop stops it from ever reading the array at index -1? Pause and find it. The answer is the empty guard. If as is empty of s, return 0. It tests whether top is -1 before we ever touch s-arrow data at index s-arrow top. A few more pitfalls are worth knowing before you write your own stack. First, array overflow on push. If you increase top and then write to that slot without checking is full first, you write past the last slot and corrupt whatever memory follows. Second, leaking linked nodes. If you pop without freeing the old top, or forget to drain the stack before the program ends, you leak one block per node. Third, confusing the two tops. The stack's top of stack and the memory diagram's top of the stack region are different things that just share a name.